Hello, I am Aditi Patange, Product Manager for Zero Trust DNS, and in today's session, we are going to talk about DNS and Microsoft's latest innovation in DNS security, Zero Trust DNS. In this session, we will see the innovation of DNS security over the years, deep dive into Zero Trust DNS with a demo, followed by practical deployment guidance to get Zero Trust DNS up and running in your environment. We want to make sure that Zero Trust DNS best caters to your existing challenges, so there will be a survey towards the end where you can tell us about your needs. Throughout this session, feel free to drop your thoughts and questions in the comment section of the tech community page for this event. As you may already know, DNS is the phone book of the internet. It resolves domain names like Microsoft.com to IP addresses like 1.2.3.4. When DNS was first designed in the 1980s, it was designed to be functional, not secure. The protocol was plain text, which allowed hackers to see every domain you looked, and also alter the resolutions to redirect you to a different page. With the advent of encrypted DNS in the 2010s, attackers could no longer see what domains you resolved, and altering the responses on the wire also became much harder. However, encrypted DNS didn't know whether a domain was good or bad, and malicious or compromised domains used for phishing, malware, or data exfiltration could be resolved with encrypted DNS. So, protective DNS was standardized in the 2017 to 2021 timeframe with the idea of treating DNS as the security control plane. Protective DNS applies active inspection and policy to every DNS resolution using threat intelligence and analytics to block malicious or risky domains in real time. Now, we have intelligent DNS server that doesn't resolve malicious domains, but attackers can still bypass protective DNS by hijacking the client device to use a different DNS server or issue direct IP address connections to malicious endpoints. To close this gap, Microsoft announced Zero Trust DNS for Windows 11 devices. When configured, Zero Trust DNS enforces the use of protective DNS on Windows 11 devices, and it blocks all outbound IP connections by default. If protective DNS is the policy engine, Zero Trust DNS on Windows 11 acts as the policy enforcement point on the client. You may wonder, what is Zero Trust DNS? So Zero Trust DNS or ZTDNS is a new enterprise security feature in Windows 11 that acts as a policy enforcement point on the client device for all of your policies that sit in the protective DNS server. And it mandates the use of encrypted DNS. All policies exist on your DNS server like they do today. DNS server remains the policy engine, and with Zero Trust DNS, Windows has an inbuilt client-side policy enforcement point that makes it much harder for threat actors to bypass policy that is set by the enterprise IT admin on your device. ZTDNS is off by default and needs to be configured by an IT admin. When enabled, Windows will block all outbound IPv4 and IPv6 traffic by default, only allowing connections to IP addresses resolved by the trusted configured protective DNS server. This follows the Zero Trust principle of deny by default and allow by exception for a limited time. From a licensing perspective, Zero Trust DNS is included in your Windows 11 Enterprise and Windows 11 Education editions. Now let's see how does Zero Trust DNS actually work. When Zero Trust DNS is enabled on a Windows 11 device, Windows blocks all outbound IPv4 and IPv6 traffic except connections to the protective DNS server, as well as essential network traffic like DHCP, DHCPv6, and the Neighbor Discovery Protocol, NDP. When applications need to connect to a destination, they query the protective DNS servers using encrypted DNS channels like DNS over HTTPS or DNS over TLS. using the Windows DNS client or ZTDNS client. Then the protective DNS server evaluates the domain against the configured policies, only resolving allowed or non-blocked domains. For approved domains, the protective DNS server returns the IP address to the same encrypted DNS channel. Windows creates a temporary allow rule for that address for a specified amount of time. Some applications, including teleconferencing apps like Teams, don't discover endpoints through DNS, but they publicly document their necessary subnets. Zero Trust DNS allows admins to configure static exceptions for those IP addresses. Now, back to this example. The requesting application is able to send a query to the web server because we have a just-in-time allow exception for that IP address. Any traffic that is trying to go to IP addresses not resolved by the protective DNS server or that do not seem to be on the manual exceptions list configured by the IT admins remain blocked by default, adhering to the deny by default zero trust principle. Whenever I'm talking about this to an IT admin, they say that sounds great, but they often ask if they have to manually keep track of every domain in the allow and block list on the DNS server. And how difficult would that be? The short answer is you can, but there are easier options. The easiest would be to use an existing protective DNS server offering. And many providers out there like Akamai, Cloudflare, Infoblox, Realbone have existing turnkey protective DNS services that your enterprise can leverage. Some of these offerings are free and then the others are paid. You can pick and choose based on what suits your needs the best. Next, a medium effort option could be that you host your own DNS server, configure it to use DNS over HTTPS or DNS over TLS. Recently, our team has also announced DNS over HTTPS preview for the Windows Server 2025 DNS server role. Please go check out our blog post and try out the preview. You can then leverage existing community-maintained block lists to build policy on top of your existing DNS server. And lastly, you can have the high-effort option of managing your custom policies on the DNS server. This gives you full control over your DNS infrastructure. You can customize it based on however granular you want the allow and deny lists to be, whatever suits your needs the best. However, this does require a dedicated DNS security team as well as work into ongoing threat intelligence. And now you're going to see Zero Trust DNS running in action on a Windows 11 device. In this demo, we are going to see how Zero Trust DNS can protect your enterprise by enforcing policies in your protective DNS server. As you can see, we have this Windows 11 device configured to use DNS over HTTPS with 1.1.1.2, which is a protective DNS server provided by Cloudflare. And this is TeamWiki, an internal knowledge base used by this enterprise. It looks perfectly normal, but this app has been compromised. An attacker injected malicious content into the onboarding guide. While most employees and admins won't even notice it, new employees will likely fall prey. The attacker is redirecting users to malware.testcategory.com, and if that doesn't work, they have a fallback, a direct IP link that downloads malware. Let's see what happens if we click on these links. Since browsers can bypass system DNS by using their own DNS settings, the first link to malware.testcategory.com resolves and loads. The second link to a direct IP address also works and downloads malware.txt. Both attacks succeed even though this device was configured to use protective DNS. Now let's enable Zero Trust DNS with the same protective DNS server. We have now configured 1.1.1.2 as our trusted server for Zero Trust DNS. And with this command, we have now enabled Zero Trust DNS on this device. Let's go back to the onboarding guide on our Team Wiki. Let's refresh this page. And now clicking on the first link doesn't work because Zero Trust DNS prevents apps from using their own DNS, and everything must go through the trusted resolver. In this case, 1.1.1.2 blocks the known malicious domain, and Zero Trust DNS ensures that policy is honored on the device. Clicking on the second link also doesn't work because Zero Trust DNS blocks all IP addresses by default unless they were resolved through the trusted DNS server. Thus, attackers' backup plan has also failed with the use of Zero Trust DNS. While these malicious endpoints are blocked, legitimate traffic still works perfectly. Microsoft.com resolves through the trusted DNS server and loads without any issues. Now let's dive into the practical steps of how you can get Zero Trust DNS up and running in your enterprise environment. We think of this in 4 steps. First step is to validate and make sure that Zero Trust DNS works in an isolated lab environment. Next is getting your fleet ready, ensuring that all of the Windows devices within your fleet are ready to accept Zero Trust DNS. 3, running it in audit mode. Zero Trust DNS has 2 modes, audit mode and enforcement mode. In audit mode, your device functions like before, but Zero Trust DNS logs all connections that would be blocked when it is running in enforcement. This mode is meant to ease deployment of Zero Trust DNS. And lastly, we have the enforcement mode, where you have Zero Trust DNS rolled out in enforcement mode to all of your fleet. Let's dive into each of these steps into a bit more detail. So the first step is to validate Zero Trust DNS in a lab setting. Test out Zero Trust DNS with your protective DNS server on lab machines before you touch production. Deploy a few Windows 11 enterprise devices in an isolated lab environment. Configure Zero Trust DNS using the netsh commands and point it to your protective DNS server. Next, verify that encrypted DNS connectivity is working using your choice of the protocol, DNS over HTTPS or DNS over TLS. Confirm that all of the resolutions for approved domains work and they fail for blocked domains. Test out enterprise applications like Microsoft 365, any of your custom business applications or third-party software that you need, and document all manual exceptions needed for services that use hard-coded IP addresses or non-DNS discovery mechanisms like WebRTC. And throughout all of this process, if you run into any issues, feel free to reach out to our team at ztdnsteam@microsoft.com. And we are happy to assist and would love to hear your feedback on your validation results. Next step is to getting your fleet ready. If you're still running Windows 10, it's time to upgrade. Upgrade all of your target devices to Windows 11 Enterprise or Education with the latest cumulative update. Then, start using DNS over HTTPS or DNS over TLS by default. You can configure the client side of DNS over HTTPS or DNS over TLS using group policy and try out the DO server preview on Windows Server 2025 and see if just encrypted DNS by default works in your deployment. Next up, we recommend to start managing configurations on your Windows devices using Intune. However, if there is another MDM of your choice or you want to use group policy to manage your Windows 11 device, do reach out to our team and we would love to learn about your preferences. Next up, step 3. We are going to slow rollout in audit mode. When you have tested out Zero Trust DNS in your lab settings, you're getting your fleet ready with all of the Windows 11 builds, you want to monitor and learn before you enforce. So audit mode gives you that safety net. Start deploying ZTDNS in audit mode to an initial pilot group representing diverse application usage patterns, but also making sure that they continue working because now audit mode is logging all expected blocking behavior without actually blocking it. Monitor ZTDNS logs in the Windows Event Viewer for connection attempts that would have been blocked in the enforcement mode, and start analyzing those logs to identify legitimate applications or services that will require manual IP exceptions. Continue updating your exceptions list based on what you find. Now slowly start rolling out ZTDNS in audit mode to your fleet with additional users, different departments, and give it sufficient saturation time so that you have captured full range of application behaviors across all of your diverse users within your enterprise. And lastly, ensure to collaborate with application owners and service teams to validate any exceptions they may need for endpoints that are not discovered via DNS, but are necessary for business continuity. And the final step is to roll out ZTDNS in enforcement mode to all of your fleet. Start with your initial validated pilot group, get them to move on to the enforcement mode, continue monitoring your event viewer logs, any user reports of unexpected impact to legitimate business applications, continue maintaining your manual IP exceptions list, monitor your devices, and then slowly roll it out to your entire fleet. Maybe give it a week or two of monitoring time between the expansion phases. And throughout all of this phase, and also after you have rolled out ZTDNS to all of your fleet and enforcement mode, we recommend that you continue reviewing your ZTDNS logs, your protective DNS server policies, and any exceptions list that you have periodically, because the threat landscape is always changing and your business needs probably are also evolving. And lastly, we have some resources for you. Zero Trust DNS, as we said, is available on Windows 11 Enterprise and Windows 11 Education editions today. So please do go try it out. We have a link to ak.ms/ZTDNS, which you can check out for more information, or you can also contact our team at ztdnsteam@microsoft.com for any help you need. Before I let you go, as promised, I have a survey for you. We want to learn from you and we want to understand your needs better. So please scan this QR code to fill out a quick survey that helps us understand your organization better, as well as an opportunity for you to give us feedback on Zero Trust DNS. With that, I want to thank you all for your time today, and I hope you enjoy the rest of Microsoft Tech Takeoff. Thank you.